Kunststoff nachgefragt. Der SKZ-Podcast.
You wouldn't believe that Brewdog beer needs infrared emitters because the labels on the bottles wouldn't stick without the drying outside.
Hello and welcome to Plastics Requested, or as we called it in German, Kunststoff nachgefragt, the SKZ podcast. Two things are always the same, and that's my colleague Alexander Heffner and me on the microphones. Hello Alex, happy to have you.
Hi Matthias.
And what is also always the same are three main topics, and these three topics are this time deburring, infrared emitters and hot runners. Alex, what's up to that?
Well, that's three big topics. I don't know. I already learned some new vocab since deburring sometimes is also known as deflashing. So what it is when processing plastics, especially in injection molding, unwanted burrs or flash can form, and obviously you don't want that. And I remember helping out in our student lab where the students produce spoons just for learning purposes, but they have the little burrs, and what happens is we sit around with a sharp knife and cut off the burrs. To talk about a better solution for deburring, we invited two people who know better than us.
Absolutely right. And these two people are Marie-Luise Bopp. She is Senior Marketing Manager at Excelitas Noblelight. Hello, Marie-Luise.
Hello.
And Jörg Wöll. He is Head of Sales, EMEA Industrial, also at Excelitas Noblelight. Hello, Jörg.
Hi, grüß Gott.
So, as we know it from our other SKZ podcast episodes, our guests will introduce themselves. So, ladies first, Marie-Luise, how did you start at Excelitas Noblelight? What is your current job and how do you spend your time there?
I'm a natural scientist and completed additional training in marketing. My dream job is to do marketing for technological products which need explanation in the B2B area. And these products have special challenges in marketing for the materials, the target group, the channels you can use. And this is my daily job and I love it.
Perfect. Jörg, what about you? What are you doing as Head of Sales, EMEA Industrial at Excelitas Noblelight, and how do you spend your time there?
Yeah, my origin is mechanical engineering, and I'm now since 15 years with the Excelitas Noblelight, former known as Heraeus Noblelight, and I'm responsible for selling our UV and infrared products and solutions together with a European-wide team to our customers and improve their processes. That's my daily job.
Then, Matthias, I would say we start with our first question. Well, first of all, why is deburring such a relevant topic? And Marie-Luise, do I still have to imagine some people with sharp knives in industry preparing the products before they go into sale? Or is there a better way?
I hope there is in the meantime. I remember that when I had a summer job or holiday job as a student, I worked in a company doing injection molding and produced thousands of little plastic parts every day, put them all on a big table, and a group of students sitting around the table with little sharp knives were deburring. We were chatting and joking and having a lot of fun. Some were careful, others were not so skilled. I hope the results in the end were not too bad. So it was not until much later when I joined Noblelight when I learned what we had done at that time and how much better we could have done with infrared radiation. And I think by now the manual work is not as much as it used to be, but it is still in the field. Jörg, right?
Absolutely, Marie-Luise. We see this manual work still with a certain number of customers, and that is really our everyday job to tell them, hey, there's a better way to do it. for example, with electrical infrared emitters and infrared radiation.
So in this case, guys, please tell us, how does deburring with infrared emitters work?
The infrared emitter, you radiate infrared, and this heat, this energy, it is melting the burr. That is the difference. It's not taking the burr away like with a knife and you cut it and take it away. No, with the infrared, you melt it and you make a very smooth surface, and you can follow the contour or the shape of the plastic part with a contour emitter, electrical infrared emitter, following directly the shape, and it is really radiate the infrared energy directly on the burr and reduce and melts the burr away.
That sounds good, but now the big question. Is IE deburring faster than a trained summer worker like Marie-Luise or me? And what about the quality? I'm sure it varies more if you have the summer workers, but is it a constant quality? Is it improved? How does it simply feel when I touch it?
Jörg, may I? I've got here some quotation from a former colleague of us, and he said that he knows customers who have already carried out more than 500,000 deburring cycles with the same infrared emitter set, and the result is always the same. And I don't think a summer worker can do that similarly.
I guess the machine did not have as much fun as you summer workers have.
That's for sure. But unfortunately, let's say the end customers of our customers, they really looking for a high quality, and they really need the repeatability and the repeated high quality level of their products. And I know, and I can imagine if you start the deburring, the manual deburring, and with a knife and cut the burr away, it maybe works in the morning. In the lunchtime, you're thinking of your lunch, and I'm pretty sure then during the day, in the afternoon, you're getting a little bit tired before you stop working, and the quality of the work is different, and that is, like Marie-Luise said, after 500,000 parts, still the same result and still the same quality, even if they do not have this much fun like Marie-Luise and Alex did have during their manual work, for sure.
What about speed? Is it as fast as our summer workers or even faster?
Normally it takes really very, very short period. It's maybe 1 to 2 seconds, maybe 3, sometimes up to 5 seconds. The emitter is running for the deburring process. And that is, I guess, the same speed or even faster than do it manually, especially if you have some parts that have a special contour and you have to move the part. And with a banded infrared emitter, that's not really needed. And you really can transport the part to the emitter directly in front of the emitter, or move the emitter directly in front of the part. And I guess at the end, it's faster, even sometimes much faster than manual work.
Yeah. And we have one customer, they plan to have a new machine for deburring. So they made test and calculations for deburring with hot air blowers and with infrared and manual work, and found out that infrared would pay out in the end much quicker.
So making it totally easy from the point of explanation for all our listeners which are not experts in this field, more or less, you heaten up the article or the newly produced part, and so the deburr will melt in this case, and you have a very smooth part. So making it, like I said before, totally easily from the explanation point of view, couldn't you just use hot air instead? And what are the advantages of ER compared to hot air or manual deburring?
First of all, Matthias, you can use hot air. It is a very common process, but what you always have to consider, if you use hot air, the air, it shows a lot of dust in the area. And if your part needs some clean surrounding and you're blowing hot air and the particles around your part, that can cause some problems at the deburring process itself because of some parts that are now, instead of the sharp edge, sharp burr with the product, or later on, if there's sticky, plastic parts, small plastic parts are sticky on the part, and you want to coat them later on, that will disturb the coating or even sometimes not allow further coatings. Regarding the manual cutting of the burr, we see quite often the problem, especially for coated parts, if the burr is still a little bit sharp because of the knife and you cannot come really to the ground of the burr, to say. That is with infrared possible. As we melt it and we round it, then the quality of the burr is much better because it's not sharp at all. And especially for some coating processes, this causes a lot of problems if you still have some sharp burr, or even if you use it in some critical areas, like for the steering wheel, and you touch your steering wheel and there is a sharp edge, that really is a risk to get hurt, or you have really a cut on your fingers. And this is not the case with infrared.
Yeah,
Okay.
absolutely understand.
Okay, so far it's easy. We've heard a lot of advantages. Now, what about energy consumption? Like, it's a summer job, so Marie-Luise and I would be happy about some air conditioning. But what is the energy consumption of your infrared emitters? Will it be very expensive?
For sure not. For sure, that is, it is a very economical process. You can imagine these infrared emitters, they are really they can start within 1 second, then they're running for 2 seconds, and then they are off. And there is no need that you have to turn on the emitter like with an hot air fan. That is not needed. You really have the energy on demand. And for that reason, the infrared deburring process is a really very efficient process regarding energy consumption. Correct, Marie-Luise?
Yep. You need to switch it on only as long as the heat is needed, and the emitter also will not fail when you switch the emitters on and off quickly.
Okay, and I presume you only produce the heat exactly on the part where it is needed, while hot air method would warm up the air around it, so you know it's energy saving as well.
Right.
And there's one really another detail. We have these named slot emitters. So we have our emitters. They have a golden
reflector coating.
Reflector, and we really have a small slot only opened up to allow the radiation to leave the emitter, and this can be concentrated on the burr. Super exact. Much better, as you said, Alex, with compared to hot air.
To hot air,
and to a manual. I always think manual using the knife, it's sometimes a little bit more, then a little bit less, a little bit more, a little bit less. But this you do not have with the infrared emitter. The energy is always the same.
You know, Alex, now we are both not guys which are driving an electric car at the moment, but it's the same with the electric car. You put the pedal to the metal and you have the full power immediately on point, and it's nearly the same system, just smaller than an electric car. But you have the power exactly at this moment when you need it, right?
Good example, very good.
Thank you for
We
that.
will use it, Marie-Luise. This example we will use for our next marketing campaign.
Yeah.
Yeah. And there are some nice
All
songs
rights
for
reserved.
marketing. Put the pedal to the metal.
Yeah.
Okay, so to summarize it, under what conditions does using IR make sense? And can it be used for any kind of parts? Jörg, you just mentioned a few of parts which you could use it, but are there another parts and articles you could use this IR?
Jörg, I remember we had once a trade show where we had this as a main topic, the deburring. And we had many customers coming to the booth with a bag with their little parts. And they asked, can you do that? Can you deburr this part as well? And so we learned a lot. And there are, let's say, very cheap parts where it doesn't make any sense to have an expensive, highly sophisticated infrared automated system. But for car interiors, for example, high quality cars, it definitely makes sense to have an automated system with a perfect quality later.
And in addition to say, you need a certain number of parts to be fair. If it's only 1 or 10 parts a day, the infrared emitter solution is quite often not very effective. If you have 100 parts a day and you can really use infrared emitter for a certain period before you have to change the tool, then it makes much more sense. So the number of parts you are treating per day is important, if it makes sense or not. Some materials, to be fair, we can't do. Duroplastic materials are not possible to be treated with infrared radiation. Thermoplastic material is not a problem. But what we are doing really to make sure that it will work, we have in Klein-Orstheim, in our application center, we have the possibility to do trials with our customers. And this is something we do very, very often. We have done thousands of tests already in our application center. And then we can do the trial on the product. We can see the result directly, and the customer and his quality engineer, they judge, yeah, that's exactly what we need, or the contrary, in case it's not working, then it's not working. It happened, but it's not quite often that it's not working.
Okay, very good. Now, what I got is I have certain advantages. There's a high energy efficiency. It is fast. It makes sense for thermoplastic materials when I have a high production volume. And it is very clean compared to hot air. I won't have particles I don't want in my part. And it makes sense if there's a high need for a good quality and ideally no burr at all. In which industry is this technology mainly used?
The automotive industry, as Marie-Luise said, that is our main customer. But we have in all other industries as well, in general industries as well. For washing machines, for example, there is a couple of plastic parts, and people who use the washing machine, they have to make sure that there is not a sharp edge. And when they press a button or whatever on their board to run the washing machine, and a lot of other parts in the kitchen where you do some daily work in the kitchen made of plastic, they are using our infrared emitters to deburr and to prevent sharp edges. And general industry is another very, very wide field where our products are used for the deburring process.
You mentioned also before that you could use this kind of technique at big parts, but as well as on very small parts. Do you need a certain production volume that this technique is usable or not?
As I said, for the production volume, for one-off product, it makes not sense. If you have a couple of hundreds per day, then for sure it makes sense. You're right, Matthias. You need a certain volume before you have really a payoff. If it's only one or let's say 10, then you need for every different product a different emitter. That is the disadvantage. This emitter, it's really made directly following the contour of the part. And if the part change a little bit, you need a new emitter because the efficiency is directly linked with the contour of the emitter following the contour of the product. And if there is a gap too big, then the result, because of the energy is not really reaching the part in the way it's needed, is too low. And the result for the deburring is not as good as it has to be. But that's why we need really following the contour of the part and need a certain amount of parts to be treated during the shift.
Yeah, I could absolutely understand it because otherwise, if you have only one or two parts an hour or something like this, you could have your summer worker or your holiday worker or
Right.
even another skilled worker which could cut it by a knife or something like that. And also, I guess this is the technique most producers will use it when they have bigger amounts of the same product in same line, for example. So like you mentioned before, Jörg and Marie-Luise, when you have the same contour, so it's perfectly to use it for. I absolutely understand it. Another question. Like I mentioned before, in the easy way, you heaten up the part or the burr itself. And does this deburring affect downstream processes, like, for example, a painting or a coating?
You need that as an preparation before coating. Just example is you have a plastic part in automotive interior and it gets a chromating or a silver coating or what. And the silver coating will not look perfect when there are burrs or the burrs are not removed exactly or not, the surface is not rounded up or whatever, then the silver painting always will look cheap.
Even to say it will not cover the whole surface because of electrostatic process during the coating. There will be some damages in the surface of the coating due to the sharp edge, due to this material that is not melted or not taken away with infrared, for example. And as I said, and Alex mentioned it, if you have some particles on the part itself, especially for this interior and out and exterior, makes no difference. There are some particles that are sticky and due to electrostatic effects are now attached to the basic product part. Then you have some defect on the coating again, and that is really quite often causing quality problems at our customer side. And that's why they're using the electrical infrared and getting rid of all other technologies that do not have this high quality achievement, like the infrared radiation.
Okay, so downstream processes actually profit from IR deburring.
Yeah,
Very
absolutely,
Definitely.
absolutely.
Now, to be completely honest, I have a serious question. What new application and possibilities are emerging? So where's the technology headed? Because in the principle, it's just a wire in a bottle, right? So
Oh no!
I'm thinking
No.
barbecue.
No.
No?
A wire in a bottle, no. That is really,
That
Alex.
is,
Oh,
yeah, what in the old ages people used to say about infrared heating technology, a wire in the bottle, but those times are gone.
Okay, just wanted to tease you a little. But what new applications could you imagine, and where is the technology heading?
For example, vacuum processes, wherever you need a vacuum to produce things, or for example, the anti-reflex coating for solar cells, or whatever vacuum process you need. This can be done with highly developed infrared emitters, and a wire in a bottle wouldn't work, for
Okay.
example. Yeah.
in addition, we have our spot emitter recently developed, and with the spot emitter, we can deburr, let's say, even on smaller parts, what Marie-Luise mentioned during the trade show. Now it would be able with this spot emitter to do this deburring even on smaller parts. That is a new development. And to be fair, the infrared technology as it's own technology and is used in so many different industries. You would not imagine in how many industries. For example, the PV industry, yes. The e-mobility, we are in so many different heating processes involved.
But also for food and beverages, for the production of chocolates, wherever you need highly sophisticated, highly developed heat processes, where you need a small range of temperature only, or heat within the in very short time in a very short small space, things like that. For that you need modern infrared heat.
Okay, now honestly, very important question. Did you ever try if it works to grill sausages?
Yes.
Does it?
Who has thought about it?
We did test one day, and we had, I remember, many volunteers to taste the quality of the sausages. It worked very well. Yeah.
And we do this even only not for sausages. We do it for hamburgers. We do it for pizza. We have a lot of different applications in the food industry. That's why Marie-Luise mentioned it. And always when the customer is coming for trials in our application, then with some very good products, we have a lot of volunteers coming and having a look. And it smells really. It smells, it
just
looks.
Coming by and see what the guys are doing.
I just want to say, may I introduce Alexander Heffner and Matthias Ruff, quality inspector for food and beverages.
Feel free to come next time. We will let you know in advance. So there are a lot of new products, and we have some special emitters developed with a carbon filament for mainly printing and coding industry, and there's a continuous improvement of the wire in the bottle.
Yeah, and it's unbelievable which products already have seen infrared during their production process. You wouldn't believe that Brewdog beer needs infrared emitters because the bottles, the labels on the bottles wouldn't stick without the drying outside. Yeah.
Okay. So, Alex, at the end, we're seeing very interesting technique and in more branches than we thought before. So the food and beverage branch, very interesting. Also, for sure, automotive industry is always an interesting one. And I guess also the medical industry is one of a big for you.
Absolutely, Matthias. Medical is even a much more interesting industry for us, as we have our UV and infrared solutions, especially for adhesives in the medical industries. UV products, our UV LED or microwave systems are very, very often used for curing of coating,
marking and printing on little cables or
adhesives. The medical industry, that's really an emerging market. We see it. Everybody gets older, and we see that the need of products, different products, is more and more increasing. Yeah, absolutely.
Cool. Okay. So it's absolutely worth taking a look at this technique and taking a look at Excelitas Noblelight. And now with the thing of taking a look in the back of my mind, I have to take a look on the clock because we are at the last question of this kind of episode. And the last question, you both know it from our first episode together in German language, is a wish for both of you. And so my question is, ladies first, as at the beginning. Marie-Luise, do you have a wish or a vision for the future of the industry, for the company, or for yourself?
Oh, my dear. Well, I hope this is not the end of the wire in the bottle, and there are always new developments and challenging new applications for the infrared technology. I'm a fan of infrared.
Perfect. Jörg, what about you?
I would really like to increase the usage of electrical infrared systems much more, even much more than it is today, due to this carbon footprint in the future that becomes more and more an important topic for all of us, for all companies. And with green energy and our electrical infrared emitters, we have a very environmental friendly technology available in combination. And I hope that this will increase during the next years, even more than it is already doing at the moment.
Thank you very much for joining us today. It was good fun making this episode with you.
Thank you very much.
Thank you. It was a pleasure.
Thank you very much. Until next time.
Bye-bye.
Bye.
Yeah, Alex. And at the end of each episode, it's time for our little fun category, this time in English, and it calls Plastics Knowledge for Self-Defense.
Kunststoffwissen. Flexibel im Kopf, stabil im Gespräch.
It is an educational category.
Yeah, we could also say it's an educational category. So the question today is, what exactly was the plastic chair?
Quite simply, a plastic chair.
Thank you for that, Alexander.
As I said, educational. But one of the very first, the plastic chair, was launched in 1947. History education. Industrial designer Egmont Arends tried to design an extremely comfortable chair by using clay imprints of large, narrow, and medium-sized buttocks. He honestly did. According to the developer, the main advantage for the industry at the time was that a 500-ton press could mold one unit every 8 minutes. The material he used was bakelite.
You're absolutely right. And the plastic chair we all know today traces back to the Fautil 300 design by French engineer Henri Maisonnet. It was already manufactured as an inexpensive monoblock from polypropylene and is the most widely used piece of furniture of our time. So not only historical, it is only a part of modern design, I guess, Alex. So let's ask this question. Do you have one of these chairs at your home as well?
Not one of these, but I have very fancy plastic chairs for outside. Works well.
Perfect. And but you have chairs in your home, right?
I do.
Okay, I'm happy with that. So, guys, thank you very much for listening to this episode of our podcast Plastics Requested, or as we called it in Germany, Kunststoff nachgefragt. Thank you for listening. Yours, Matthias.
And Alex.
Until we hear us next time. Bye-bye.